Okay, for this next problem, we're pulling a little bit of geometry. Suppose we have a rectangle, and the perimeter of the rectangle is, say, 19.2 feet. So perimeter equals 19.2 feet. And the length is, let's call it 7.2, this should be T, feet. And we want to solve for the width. Okay, we'll start with the perimeter formula for a rectangle. So the perimeter is equal to 2 times the length plus 2 times the width. And we want to solve for the width. So I'm going to rewrite this equation so that W is by itself. So I'm solving for W. So anything that does not have a W, any terms that do not have a W in it, I need to move to the other side. Well, 2L does not have a W. So I'm going to get rid of that by minusing the 2L from both sides. So P minus 2L, or perimeter minus 2L, is now going to equal 2W. Well, remember, I'm solving for W, so I need to get rid of the times 2, so I'm going to get rid of that by timesing by a half on both sides. 1/2 of 2 becomes 1. 1 times W is just W. Perimeter is over 1, so 1/2 times P gives you perimeter over 2, or half the perimeter, minus 2 times a half is 1. 1 times L is L. So the width of this rectangle is whatever the perimeter is divided by 2 minus 1. All I have to do now is substitute these numbers in. So in place of P, I'm going to substitute 19.2, and notice that I'm putting it all in parentheses, over 2, and then from that I'm going to subtract 7.2, and that should equal my W. So make sure you use a calculator. So 19.2 divided by 2 gives us 9.6 minus 7.2 is equal to W, so I'm going to minus 7.2, and now my W, my width, would equal 2.4, and that would be in feet. I'm going to go ahead and try another formula. So let's suppose we have the Celsius and Fahrenheit formula, which is C equals 5/9 times Fahrenheit minus 32. So this formula will take a Fahrenheit number and calculate an equivalency for Celsius. Well, let's suppose I gave you a Celsius and I wanted you to calculate the equivalent for Fahrenheit. So what I have to do here is rewrite this problem so that I'm solving for F, or that F is by itself. Okay, this doesn't have an F, this doesn't have an F, but this is outside parentheses, so I'm going to get rid of this first. Well, I'm timesing by 5/9 with this whole expression, so I'm going to times this whole thing by the reciprocal, which is 9/5. Do the same thing over here, times by 9/5. The 5s will cancel each other out to a 1, the 9s will cancel each other out to a 1, and all we have left on the right hand side will be F minus 32. On the left hand side we still have 9/5 times C. If you want to call that 9C over 5, you can do that. Sometimes we just like to leave it this way. Okay, I'm still solving for F. I still have a minus 32, so to get that off of that side I'm going to add 32 to both sides. Now I can't combine these together because they're not like terms, so all I can do is express it as 9/5 C plus 32, just make room for it, equals, and then remember this is 0, Fahrenheit. So the Fahrenheit would be 9/5 of the Celsius number plus 32 more. Let's go ahead and do another general equation. Let's do A times X plus B equals C, and let's say we're solving for X. Okay, so I have an X inside, so I gotta go outside the parentheses. To get rid of this, We're going to either times by 1 over a or divide by a. So I'm going to go ahead and show it as a times 1 over a instead of a divide this time. So I'm times by the reciprocal, which is 1 over a, times by the reciprocal, which is 1 over a. The a's will cancel each other out on this side, leaving x plus b equal to c times 1 is c, 1 times a is a, c over a. And then I want to get rid of my plus b, so I'm going to go ahead and subtract b from both sides. That gives us a 0, so that x then would equal c over a minus b. We're going to go ahead and try one more of these, where we have to factor out a common term. Let's do ax plus b is equal to cx minus d. And we're still going to solve for x, so we want x equals by itself. Okay, I have x's on both sides, so I need to bring them all to one side. So I'm going to bring my cx over here, and eventually I'm going to take my b and move it this way. Alright, so I'm going to bring my cx over first. It's a positive cx, so I'm going to minus cx. So I'm going to write ax minus cx, and I still had a plus b, is equal to a negative d. All I did was get rid of the cx. Now I want to get rid of my plus b, because it does not have an x like these two do. And I'm going to put a minus b on both sides. So this becomes a 0. Now I have ax minus cx, that's a minus sign there, is equal to negative d minus b. And since these are not like terms, I cannot combine them together. However, they do have a common factor of x. So what we can do is factor an x outside, which is undistribute, also known as factoring, dividing. So if I divide this by x, I end up with an a still on the inside. If I divide this by x, that's a minus. I end up with a c on the inside. So all I did was take a x out of both these by dividing outside my parentheses. And I still have a negative d minus b. And to get this expression detached from the x, we're going to divide both sides by a minus c. A minus c. A minus c over a minus c is 1. 1 times x is just x. We still have a negative d minus b all over a minus c. Now we can rewrite this with a plus sign down here. Sometimes we don't like to have the minus down here. We would just multiply this whole thing by a negative 1. But for right now, we're just going to leave it like it is.